Good morning, good afternoon, good evening, everybody. My name is Steve Robinson. I am one of the business development guys with Galarath. If you have any questions following from this brief demonstration, please feel free to email me. My email address is srobinson@galarath.com. With me today, I have my colleague Keith Garland, who's going to walk through what we're going to demonstrate today, which is the process of estimating an assembly. This is the example on the screen is a small rib assembly, and what we're going to go through is the process of fit up, drill, and fasten using the Aero plugin within CR4 Manufacturing for Aero fit up, Aero drill, and Aero fasten. We're also going to show a little bit about how you can very quickly and very easily draw data in to SEER from Excel to speed that process up, so you can also take data from external sources, perhaps ERP systems, for instance. So we're not going to take too much of your time, hopefully about 15 or 20 minutes. So without further ado, Keith, over to you, sir.
Okay, thank you, Steve. So, hello everybody. On my screen you see an aircraft rib assembly. It's actually a case study we used during the formal training. It's 48 inches long, 14 inches across, and it consists of upper and lower chords, 2 of them, 5 stiffeners, a rig frame detail, and about 162 fasteners, which you need to put into our estimate to come up with a final assembly time. The estimate I will show you actually includes the fabrication, the sheet metal operations to create the stiffeners, the chords, and the frame. So we will just look at that very briefly before we go into more detail for the assembly process. So the process itself, the parts are manufactured obviously, and then they're brought into the fixture. The 2 stretch formed parts are placed and positioned into the fixture. They have also these ribs placed across the fixture. These are put into position onto a drilling plate where they're secured using screws. Finally, the whole thing is brought together, is drilled through, jig drilled. So we load it all together within a fixture, drill the number 40 holes, the number 10 holes in a variety of places using hand drilling. And then finally, once it's all in place, positioned, drilled, cleaned, deburred, we can then put the fasteners in where we have some standard universal rivets and other fasteners for the completeness. Some are drive-matic, and we have this variety of rivets available within CR4 Manufacturing, and we also give you the capability of adding your own fasteners into the tool as well. So that's the finished article, and we will now go through and into CR4 Manufacturing and just go through that entire process to manufacture this part. So this is CR4 Manufacturing. For those who are not aware of the model, it's a process-rich cost estimating solution from Galarath. It uses parametrics, it uses standards, and it utilizes many processes to create a variety of estimates for a variety of different processes. And as you can see, we have roll-ups, machining, fabrication, electrical harnesses, assembly, the aero operations, which we're concentrating on today, the fit up, drill, and fasten, as well as a brief look at the sheet metal and tube fabrication and more composites, etc. So just to be aware, it's a very rich tool with many processes, not just the ones we're showing you today. All the screens, so we have the work elements on the top left, where we put in the building blocks to manufacture the components, like we can see here, this top section, and then the assembly at the lower end. And this can be in any order you want, if necessary. For every line item we have here, we have a corresponding set of parameters, and the model will give us outputs and reports and charts for giving information back into the system, back into the business, back to the stakeholders, and so on. So what you can see here is the WBS, where we start with a project called Rib Assembly Case Study. It then breaks down into the details, which were the first parts we saw, the formers, the stiffeners, and the rib web. And if we have a look at this very briefly, this is the aero sheet metal operations. The general tab is common across all processes. We say what type of part we're making, how good are the people, how many we're going to make, batch sizes, any learning, step learning we can do. We can use Wright and Crawford methods and so on. The process specific then for aero sheet metal is we describe the part size, we give it a part family for the tooling, we tell it what material we're making it from, the cost of the material comes from the ini file, and you can add your own materials to that list. We don't know what you buy, we don't know how much you buy. The economies of scale for buying raw materials are very different, and the prices vary tremendously. So with that in mind, we give you that capability of adding your L165s, your fully heat treated aluminiums, aluminium lithiums, etc., as you see fit. So the process for the manufacturer within aero is based on many thousands of parts parametrically driven, and simply based upon the size of the part, we have the ability to say, what are the preform operations? We're going to route it. What are the forming operations? We're going to break form it. What are the after form operations? We're going to drill and route after form. And then finally, we're going to iodine and epoxy prime. So that's all you have to do. You just describe the operation, yes, 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 no, no, no. And for each of the parts, you will then get the individual operations. This is cut with a miter. The web is pierce blank form, NC route, route after, and everything. So as you can see, it's a very straightforward processes, and these can be captured and saved as knowledge bases, which then can drive the process very quickly, so that once a process is set within aero sheet metal, all you have to do is describe the size of the part, the area, the thickness, the length, the width, and it will generate you a cost with all of the operations captured in this yes/no format. And it also allows for batch running because of that capability within the tool to just simply select the knowledge base, enter the length and the dimensions, and it will generate you a cost. So putting that aside, we're going to focus today primarily on the assembly. So the way the model works, this is the plugin that was developed by the partners of the Joint Strike Fighter, the F-35 Lightning, and all of the partners pulled their standards together, and we desensitized them, normalized them, and embedded them into CR4 Manufacturing as the aero plugin. So this one here is the part install. So this is aero fit up. So if you imagine we have our part, and the first operations we saw on the presentation was the process of entering each of the parts into the drill jig, into the assembly fixture, ready for drilling and fastening. So we describe the finished part size, the envelope size that the part consumes, how many parts are in the assembly, the total joint length and width, which then calculates us an area. The number of drawings is there to assist in the estimation of the setup time. The part family is there to assist in the tool families that SEER can generate tooling costs for at the same time. Level of dimensional check, fastener spacings, number of fasteners, temporary fasteners, and then the process themselves of entering the parts into the assembly. So as you can see, if we double click, in this case, it's the rib web. We have one of them. We're going to clean it once. We simply position it, and we can use other mechanisms as well. We need to deburr it. There's no clamps, and it's simply a load and unload operation. The next one are the stiffeners. Now we have 5, not identical stiffeners, but 5 stiffeners that will be assembled in the same way. We'll clean them once, deburr, simply position, hold them in place with some C-clamps, load and unload due to the deburring. And that goes on through for all of the parts within the assembly. The model also allows for a common operation with an assembly, particularly on aircraft, is the shimming. So in this case, we're saying we have one area that needs to be shimmed, 10% approximately. We have the cost of the shim, no obstruction, and if I wanted to add further shimming, again, we can add your own shims, but we'll say we're going to have a clipped on, 3%, click on OK, and again that's added into the estimate, and we'll add additional time for that. Because of the assembly process, there may be surface treatments that need to be considered. We have this capability of doing fillet sealing, solvent wiping, and if I look at the list, you'll see there's a wide range of options for weather sealing, fuel sealing, fillet sealing, corona treatments, and all of the things that go on with assembly processes. So we're not just limited to adding parts here. So the parts, we can add details, machine parts, sub-assemblies, tool access, cables and harnesses, tubes, wires, flexible hoses. So we can do fitting out of aircraft with all of the cable harnesses. We can put the tube assemblies, the fuel pipes and things such as that are also covered within the model. Also, a latest addition is we have the ability to put in insulation blankets. So if we're putting in soundproofing and trim, we have a wide range of blankets and paddings that are available for insertion, and each one of these, as we'll tell it, the quantity, bonding, clipping, screwing, punching, any obstructions, complexity of installation will all roll up to make an additional time for fitting out an aircraft with soundproofing and trim. So that's the process itself. We have reports and charts, we have the quick estimates, we can do references, set a reference, we can add another detail, one of them, one clean, click on OK, and we can see that's added 2% to the cost, and I'll just simply delete that one. So you can set references, you can see the impact of that reference, and you can set up to 5 references within SEER. Make my attention to the aero detail report. It's a very detailed report for all of the aero operations available to you. So it's telling us the information about dimensional checks, shimming, load and unload times, process time, inspection time, rework time, and that will vary dependent upon the process. So that's the drilling, that's the fastening, and those reports are very detailed and allows the estimator to go into finite detail whilst doing his estimate. So we put the parts into the fixture, we now have to drill them. Again, we have finished assembly size, number of parts, number of drawings, which we can carry through from the previous work element when we insert it by copying common parameters. And then here is the process of all of the drilling operations, the automated drilling, pan drilling, and if I show you the list, there's a wide range of aircraft drilling techniques here: quackenbush, nut plate, hand drilling, counter sinking, back spot facing, reaming, dimples, automated drilling, and so on. So we select the drilling type. So we're going to drill from pilot, 100 holes, one setup, click on OK, and that would then get added to the process like before. And again, the detailed aero report has all of the times here for drilling, the hand drilling, the automated drilling. If you have any downtime percent, you can tell the model that, or if you have automated drilling like we have here, you can have robot positioning time, loading time, etc. And also, when we put the part installs in, if we have dissimilar metals, in this case we don't, there's all aluminium, we can select, we have a titanium skim or something in the middle, how thick it is, and the model will then drill at the slowest speed available. So it's going to take titanium as the most difficult material to drill through, and it will use that time to estimate the part. So that's the drilling. And then finally, once all the holes are in place, they've been assembled, deburred, wet assembled, whatever, the fasteners have to be put in. And again, exactly the same information at the top: assembly size, number of parts, length, joint area. So we can get all of that information from here and insert it. And then how many holes need to be checked? How many unique diameters do we have? And at this point, you can introduce our least, our likely, and our most. So we're capturing uncertainty. If we're not quite sure, we don't have a CAD drawing, we're just taking it off of a sketch or drawing, we can put in some uncertainty, our least, our likely, and our most. It's going to take 4 of the likely, 1 of the least, 1 of the most, and use a per mean average into the algorithm. So the fasteners are here. We have Dry-Matics 160, rivets 160, 2 solid rivets, and the growing list is here. It's a pretty extensive list. By all means, is not all the fasteners that you may use. You may use particular internal part numbering, and your part numbers, your prices can be captured and embedded within the tool as part of the development of the tool on your behalf. So you tell it what you're putting in as a solid rivet. We got 12 of them. We're going to wet assemble 100%. Torque check no, seal type no, automated no, click on OK. It gets added to the estimate and puts in for completeness. So getting information in and out of the model from Excel is quite a straightforward process. So in this case, we have the parts here, and I can take, let's say, the fasteners. So we'll take the fasteners, and I'll copy the range of fasteners to the clipboard. And we'll go to Excel, and we'll paste that into there. So what we have here is the syntax and the information required to enter information into the model. So we can, this is what the model is looking for. It's the fastener count, and we can put in other fasteners. And if I say, for argument's sake, we're going to put a load more rivets in, paste them in, make them non-wet assemble just for some variety. And we can simply take that information to the clipboard, come back to our estimate. We go here, we right click and we paste. And as you can see, they're there. Are 100% wet assembled, no wet assembly, 12, 24. So if you can get the information into a format for pasting in, it's very straightforward. And it's exactly the same for the drilling ops, for the part installs. So this one, we have our parts here, and in the same way, I can copy them out. Simply right click and copy. So it's very Windows orientated. Many of the commands are similar. Come back to our workbook, and this one here is one I prepared earlier. So if I pasted there, it would just overwrite them. Again, I put some other details, some other assemblies, and likewise, I could just copy that to the clipboard, come back, right click, and paste. And instantly, we have our assembly ready. The model has instantly done the sums. The new assembly time has been created. And if need be, we can say that was actually a mistake. We have that same capability of editing the information once it's back into SEER. And hey presto, your new estimate is complete with the additional assembly details. We'd obviously have to put a few more holes in on this one. And again, we could copy that same process or say, actually, that one is now just increased to 240, and that's all we need to do to cover the additional parts and fasteners. So that's Aero Fit Up Fasten. The model is all ready. It's reporting out. So at this level, or the top level, we have our estimate, our detailed analysis, where we can look at the total time for the manufacture of the components, the drilling, the fastening, and the assembly of that component. And that is CR4 Manufacturing, the Aero Fit Up operations, and a brief look at the Aero sheet metal operations. Thank you very much.
Perfect. Thank you, Keith. As I said, please, anybody that has any questions following from viewing this brief demonstration, please feel free to drop me a line. As I say, my name is Steve Robinson. My email address is srobinson@galarath.com, and I will gladly put you in touch with your local sales rep if it's not me. Thank you again for your time. Thank you, Keith, for yours, and we look forward to hearing from you in the future. Thank you. Bye-bye.
Welcome.